This presentation is about the structure and drying process of clay. I chose this topic because I got inspired by the classic pottery scene from Ghost with Demi Moore and Patrick Swayze, in which the main characters play with clay while Unchained Melody by Writer's Brothers is playing in the background. The scene shows the correct connection between the lovers, and even though we could debate that there are two types of chemistry here, I'm going to discuss the scientific side of it. Clay is a naturally occurring material composed of fine-grained minerals. It's generally plastic when mixed with water and hardens upon drying. It's formed over long periods of time by surface weathering of rocks in three different ways. By chemical decomposition of rocks containing silica and aluminium. By solution of rocks which contain clay minerals. These are insoluble and deposit as clay. One of the examples is granite, which consists of mica, quartz, and feldspar. Mica and feldspar are susceptible to weathering and can break down into clay minerals. And it can also be formed by disintegration of shale. There are two types of clay: residual, found in place of origin, and transported, also known as sedimentary, removed from the place of origin by erosion and deposited in a new place. Clay minerals are rare in the solar system, but are quite abundant on Earth. It has also been discovered on Mars, Europa, the sixth closest Jupiter's moon, and Ceres, the largest object in the asteroid belt between Mars and Jupiter. Molecular aspect of clay structure became better understood in the 1930s when X-ray diffraction has emerged. Clay consists of hydrous aluminium phyllosilicates and sometimes contains impurities such as magnesium, sodium, calcium, potassium, or iron. It's composed of sheets of tetrahedral silicate linkages, SiO, and octahedral coordinations of aluminium oxide, AlO4, and other minerals. Clays are classified into two main categories, 1-to-1 and 2-to-1. 1-to-1 means that there is one tetrahedral sheet and one octahedral sheet in each layer, and 2-to-1 means that there are two tetrahedral and one octahedral sheets in each layer. Sometimes in between the layers there are substitutions, for example hydroxides or cations. Different arrangements of sheets result in different types of clay. In the top right corner you can see a very simplified representation of the structures. Kaolinite belongs to 1-to-1 category and has no substitutions in between the layers. Chlorite is a 2-to-1 clay with a hydroxide sheet in between the layers, and montmorillonite and illite are 2-to-1 type of clays with cationic substitutions. Various substitutions and arrangement of coordinations give clay different appearance and properties. Studies have shown that clay is very good at absorbing hydrocarbons from petroleum-contaminated soil. Plasticity of clay depends on its chemical components. When clay dries, it becomes harder because water evaporates and the minerals come into contact with one another. This causes the clay body to shrink. Depending on the size of grains, different types of clay shrink to different extent. Clays with smaller particle size shrink more and are stronger when dry. It's important to dry the body uniformly, as uneven drying causes cracks, which might make the material burst. Transformation of the material from plastic to stone hard involves primary air drying, followed by firing in a kiln, where the clay undergoes 5 stages. Initial kiln drying at 100 degrees is when the boiling point of water is reached gradually to ensure slow evaporation. Otherwise, water vapor formed inside the body could make it burst. Dehydration at 350 degrees. At this stage, water that is part of the structure evaporates. This is different to the previous stage because in initial kiln drying, only water in between the clay molecules evaporates. Burn off at 900 degrees. Here, organic and inorganic materials are burned off. These include carbon and sulfate. It's important not to breathe in these substances, and for this reason the kiln needs to be well ventilated. Quartz inversion at 573 degrees. At this temperature, quartz crystals rearranged in a slightly different order. The body expands slightly. Vitrification at varied temperatures. At this stage, the body hardens and tightens as various components of clay are melting. Thank you for watching. I hope you found it enjoyable. And these are the references for my pictures.